Hello, this is Guillermo Campitelli and I'm going to explain the resampling approach to parameter estimation, again very briefly. Okay, so the procedure for the resampling approach is obtain a sample of participants that is representative of the population of interest, so this is the same as the other two approaches. Obtain a sample statistics, that's the same as the other approaches. Now the third step is different. Create a sampling distribution by resampling. So in the two other approaches, the sampling distribution is created by using a theoretical probability distribution. We use the binomial in this case, but in other cases we are going to use the normal distribution a lot. So the sampling distribution in the resampling approach is the step that makes it different than the others. And then make an estimate of population parameters using the created sampling distribution. That's the same as in the other approaches. In the traditional approach, we use the sampling distribution in the Bayesian approach. We use the posterior distribution, and in this approach you are going to use the distribution that comes from resampling. Okay, so the process to create the sampling distribution by resampling, there are different processes, there are different methods. I'm going to explain one of them. Basically, the difference with the other approaches is that we don't have to care about probability distributions. We create a new distribution by ourselves. So how do we do it? Okay, we use the values of the sample. So in this case, we are going to have 50 yes values and 200 no values. Yes. In other cases, we are going to have numbers. Okay, so we use these values to create the sampling distribution. The way we do it is from these 250 values, we choose one value by randomly choose one value. We write it down and we put it back in the set of 250 values. We do that again. We randomly choose another value. We write it down. We do that again and again and again 250 times. So we create a new sample of 250 values based on the 250 values that we have in our sample. Okay, so we do that and we calculate the yes count of that sample. Okay, so we generated a new sample of 250 values, and those 250 values, some are going to be yes, some are going to be no. So we calculate or we count the number of yes values on that new sample. So we record that yes count. Okay, so we did this process 250 times to create one sample of 250 values. Now what we do is to do this process thousands of times again. So we create 10,000 samples of yes counts based on samples of 250 values. Okay, so now that we've got these 10,000 values, we create a histogram with those values, and that histogram is here. That's what I did with the software R. I created the sampling distribution. So we do that. We do the same as in the other approaches. We will find the 2.5% interval percentile and the 97.5 percentile, and those two values will give us the confidence interval of the estimation. Okay, and the mean of this distribution will be the point estimate. Okay, so basically this is the last approach. The traditional approach requires a sampling distribution. The Bayesian approach requires a sampling distribution, and it generates a posterior, and the resampling approach generates a sampling distribution by resampling the values in the sample. So it doesn't have to care about binomial distributions, normal distributions. We generate a new distribution based on our values. So this finishes the parameter estimation videos.